Good day, everyone. Welcome to lecture number 27 of computer programming. And in this particular lecture, we will be mostly discussing about the pointers in C in functions. What does that mean? We will discuss the first thing, how to return pointers from functions and how to pass pointers as arguments. And in the same discussion, we will discuss how to pass arrays to functions as arguments. Okay. So before discussing these two concepts, we will discuss some important points that we have left behind in case of pointers. And after completing those points, we will come to the discussion related to the pointers in functions. The first thing that we will discuss before discussing the pointers in functions is the discussion about what is the dangling pointer, okay, null pointer and wild pointer. So we have to discuss what is a dangling pointer, what is a null pointer, and what is a wild pointer. Okay. So dangling pointer. So it is a pointer. A pointer is called a dangling pointer if it was pointing to some memory, and that memory has been deleted or freed. Okay, so that particular pointer is called a dangling pointer. For example, let's say int star p. Okay, so here we have declared a pointer p. So here p is a pointer. It is an uninitialized pointer. That means right now it has a garbage value. An uninitialized pointer or a pointer containing a garbage value, that pointer is called a wild pointer. So here p is a uninitialized pointer that is not pointing to any memory location, or we can say it has a garbage value. Okay, this pointer is called a wild pointer. Okay, so wild pointer is an uninitialized pointer. Now if I am doing p is equal to, for example, int star malloc, let's say 8. So here I am creating in memory, I am allocating 8 bytes of memory. And now this p points to that particular memory. Now p is pointing to a memory, some valid memory. So this is not a wild pointer. So here in this line, p was a wild pointer. It was an uninitialized pointer. But here we are initializing p. So it was before this particular instruction, it was a wild pointer. Now it is not a wild pointer. Now if I am doing free p, so that means this p was pointing to the memory, this p. And now I have deleted that memory, or we can say I have freed that memory. Okay, so in this case p becomes a dangling pointer. Okay, now let's say, for example, this p was here, this p was pointing to memory 2000. Okay, so using malloc I have created 8 bytes of memory. Let's say that memory was starting from 2000 to 2007 and p was pointing here. P means that p pointer contains 2000. Now we are freeing this memory. That means this memory has been freed. Freed means that this program has not been allocated this particular memory after freeing this. So it cannot access this memory. Now if we dereference P, dereference P means getting the value stored at this address, at the address P. So if we dereference, so please understand this term, dereference. Dereference means getting the value stored at the memory address. So this means dereferencing P. So dereferencing a pointer, getting the value stored at the address stored by this particular pointer. So if we dereference this particular pointer, that means we want to get the value at this location, at location 2000, but this location has not been allocated to us. So it will result in illegal memory operation, and this illegal memory operation will result in segmentation fault. Okay, so what is a dangling pointer? A dangling pointer is a pointer that was pointing to memory, and that particular memory has been freed, or that has been removed, or that has been deleted. Okay, or we can say a program was using some memory, and some pointer was pointing to that memory. Now that memory has been deallocated. Deallocated means it has not been given to that particular program. So that particular program cannot access that particular memory, and in that case that pointer becomes a dangling pointer. Okay, so we completed the discussion about dangling pointer. What is a dangling pointer and what is a wild pointer? Wild pointer means uninitialized pointer. Now comes the null. Okay, what is a null, or it is also called what is a null pointer? Okay, so null pointer it is written in capital words here, null pointer. Null pointer is a pointer which is pointing to nothing. Okay, for example, if we are declaring a pointer int star ptr, and at the same time I am writing int ptr is equal to null. Okay, so here I am saying that ptr is a pointer and it is not pointing to anything right now. Okay, pointing null in most of the C implementation, null means 0. Okay, so null is a value. Which value? 0 value. 0 means in some implementation, it is not necessary that in all C implementations null means 0. In some other implementations, null may have some different meaning. Here, null means that this pointer is not pointing to any memory location. So if you dereference this pointer, printf, that means, for example, if you are doing %p, P means the P means the address. It will print the address. If I am doing printf %p ptr, so value stored in ptr. So value stored in ptr will be nil. It will, in some implementations, it will print nil or it will print 0. Okay, so this kind of pointer that has been given value null, this pointer is called a null pointer. That is not which is pointing to nothing. Okay, so what is the difference between uninitialized pointer and null pointer? So, or we can say wild pointer. Wild pointer means uninitialized pointer, and null pointer. So wild pointer or uninitialized pointer, it points to an undefined location. Undefined location. Or we can say it means that it points to a garbage location, some random location. We don't know about that random location. Null pointer means that it points to nothing. Okay, so it does not point to anything. So we completed wild pointer, null pointer, and the another one was dangling pointer. So for example, if I am doing like this, int star p. Okay, so if somebody says what is p here, p is a wild pointer. Now if I am doing p is equal to malloc and then 8, so I have to typecast it malloc 8. Now p is an initialized pointer, that means it points to some valid memory location. If I am doing free p, now what is p after this? P is it wild pointer? No, it is not a wild pointer. It is currently a dangling pointer because it was pointing to a memory and that particular memory has been deallocated. Now if I am doing p is equal to null, so what is p here? P is a null pointer. Okay, so that means these are different. So null pointers, wide pointers, null pointer, dangling pointer, and wild pointer, they are three different concepts. Now another concept is wide pointer. What is a wide pointer? So we have used the concept of wide pointer in dynamic memory allocation, but we will discuss it here. What is a wide pointer? So for example, if I say what is an integer pointer? Integer pointer will be int star. So this is an integer pointer. What does that mean? Integer pointer. Integer pointer means that the pointer, this particular pointer is pointing to integer. Okay, wild pointer will be like this, wide star. So this is a wide pointer. Wide pointer means a pointer that is pointing to a data, and that data may be anything. It can be an integer data, it can be a for example float data, it can be a character data, whatever data. Okay, so let's take an example. For example, if I am doing wide star p, okay, now if I am writing int a and float b, int a and float b, I can do p is equal to and a, p is equal to and b. So here p is a wide pointer and it is pointing to integer. Here p is a wide pointer here, but it is pointing to float. So let's say I am doing printf %d printf %d star p. So I am asking it that you have to print the value stored at this location. What is this location? So this is p. P is a wide pointer. So what type of pointer it is? Wide pointer. So let's say it is storing this address of a. So let's say this is our memory and a was stored here. So let's say integer occupies 2 bytes, so 2000 and 2001. Let's say it was storing 2. And here p is a dangling pointer. Oh, sorry, p is a wide pointer and it is storing the address of a. Now we are saying print the value stored at this address. So it will go here. It will print the value. But how many bytes will it take? Should it take 2 bytes, 4 bytes, or 8 bytes? So it depends upon the type of pointer. For example, if it is an integer pointer, it will take the value stored at how many bytes? 2 bytes. If it is a float pointer, it will take value stored at how many bytes? 4 bytes. Now here P is a wide pointer. Wide pointer means that it is pointing to any location and it does not know what type of data is this. Whether it is an integer data, whether it is a float data or character data. So that means when we are dereferencing a wide pointer, so here we are dereferencing a wide pointer, we won't be able to fetch the correct number of bytes. Okay, so we don't know whether we have to fetch 2 bytes, whether we have to fetch 4 bytes, or whether we have to fetch only 1 byte. So here comes one important concept, that you cannot dereference a wide pointer. Why you cannot dereference a wide pointer? Because a wide pointer can store an address, but when we are dereferencing it, we don't know how many bytes we have to take from the memory. So we don't know whether it is pointing to an integer, whether it is pointing to a float, whether it is pointing to a character, because we only know one thing, and that is it is a wide pointer. It can point to any data. We can do P is equal to AND A, and we can also do P is equal to AND B. So what you have understood, we cannot dereference a wide pointer. A wide pointer is not dereferenced. So let's say, for example, here I have stored the address of A in P. P is a wide pointer. Now if I want to get the value stored at this P, so what I have to do, I have to inform my compiler that treat this, for example, treat this particular pointer as an integer pointer. It is a wide pointer, but I want it that treat it as an integer pointer. For example, if you are using 5, this is a number, and this is an integer number. Now if in your program you want your program to treat this number as a floating point number, then you have to typecast it with this float. So this is called a typecasting. Typecasting means that we are asking our compiler, or we are asking our computer, that treat this 5 as a floating point number. It is not a floating point number, but treat this as a floating point number. So here also, when you are dereferencing a wide pointer, or when you are using a wide pointer, you should typecast the pointer to an exact value. Exact means the type of value that you want to use. So here we know that P is a wide pointer and it is pointing to an integer. So if I want to dereference this pointer P, I have to typecast it. For example, I will say that treat this P, this particular P, so you have to treat it as an integer pointer. So let's say I am writing it like this. Here, for example, int A, then I am doing wide star P, then P is equal to AND A. Now if I have to print the value, printf, so %d, what I am going to do, I will first ask my computer that treat this P as an integer pointer. So I will convert it into, I will typecast it with integer pointer, and then dereference the value. Dereference means star. So it means that it asks the compiler, treat this P as a integer pointer. Now get the value stored at that integer pointer. Getting the value means use this indirection operator. Okay, this is how we use wide pointer in our C programming language. Now somebody will say, why we are using a wide pointer? Why can't we simply use an int pointer? So see the advantage here. One advantage here what I am showing is that here you are using P to store the address of A. Now if you have, for example, float B, you can use same pointer to store the address of B. Now here it is storing the address of B. So instead to declare another pointer that is a float to store the value of B, we can use the same pointer to store different addresses at different values. However, when you are using this pointer, you should dereference, or we can say you should typecast it to an exact value, to a correct value. So what is a wide pointer? So this is a wide pointer. Wide pointer means a pointer that can point to any data. any data. Okay, but you have to remember we cannot dereference it, and also we cannot dereference it, and the second thing is that we cannot do arithmetic operations on void pointer. Okay, so we completed the discussion about the dangling pointer, null pointer, void pointer, and void pointer. So in our dynamic memory allocation, we were saying that we use malloc and calloc, and both these return void pointer. Void pointer. So to use these void pointers, we were typecasting these to correct data type. Okay, so using a typecasting, we may be using int star or we may be using char star. Char star means treat the memory allocated as character memory. Treat the memory allocated as integer memory. That is what we were doing in dynamic memory allocation. Okay. Now let's come to the discussion about the functions. How to pass values in functions. Okay. So we already know that, for example, we already know that to declare a function. So when we are declaring a function, we were doing, for example, so first was return type, then name of function and arguments. We said return type means what type of data this particular function is going to return. So return type, we have discussed, it can be int, it can be char, it can be double, or it can be any other, for example, float. However, in functions, this return type can also be a pointer. So that means the function is returning a pointer. So what type of pointer? It can be an integer pointer. So if the return type is integer pointer, it will be int star. If return is a character pointer, it will be char star. If return is a double pointer, it will be double star. Or if it is a float, it will be float star. So that means a function can also return a pointer. Pointer means that it can return an address. Okay. Also here arguments, we said that argument can be an int, char, double, or anything else, but you have to remember the argument can be a pointer as well. So pointer means that it can be an address as well. Argument can be an address, or we can say a pointer. Okay, so previously we were saying that argument can be an integer, character, double. That means we were saying that argument can be some value. So a function can have argument as value, or it can have an argument as address. So if there is an argument which is a value, that is called a pass by value or call by value. If the argument is an address, then that argument is called call by reference. Pass by reference or call by reference. Here call by value or call by pass by value. For example, let me give an example. So let me write a program. So let me write it on the new page. So let me write this program here. sorry, let me declare a function. So this is a function. So what is the name of this function? The name of this function is test. And what is it is returning? It is returning an integer pointer, or we can say it will return the address of an integer. Okay, address of an integer, and it is taking two arguments. The first argument is simply a value x, okay, some value, and second argument should be an address. First argument should be a value, second argument should be an address of an integer. So that means this particular function is returning a pointer. So here it is returning a pointer, and it is also taking two values. One value is a simple value and another is a pointer. So let me define this particular function. You can define it here only. So it is your choice. Test int a int star b. So let's define it. For example, let's say it is saying int c is equal to a is equal to 10, and this is a pointer, so star b is equal to 20, return and c. Okay, now let me write the main function. Int main, okay, int a is equal to 5, b is equal to 10. So int star b, so let me write it here. Printf a is equal to %d, comma b is equal to %d, a comma b. Then I am doing p is equal to test, okay, test, and the values that I have to pass, the first should be a simple value and second should be an address. So let's say we are passing a and we are passing address of b. Okay, so after this function, let's do printf a is equal to %d, comma b is equal to %d, and star p is equal to %d. Then we have a comma b comma star p, and return 0. Let's see what is this program going to do. So int a is equal to 5, b is equal to 10. So that means in memory. So this is our memory. So what I am in main function. So I am creating a as 5 and b contains 10. So let's say a's address is 2000 and b's starting address is 2002. Let's say, for example. Okay. Now int star p, I am creating a pointer p. So am I giving any value in this pointer? No, it will be a garbage value. So this pointer is a wild pointer here. Now I am doing printf a is equal to %d, b is equal to %d. So this is my screen. Let's say this is the screen. So on screen we are printing a is equal to %d. What is the value? A, that is 5. And b is equal to %d. What is the value? 10. Okay, so a is printing 5, so b is giving 10. Now we are doing p is equal to test a and b. So we are calling this function. Let's see what is this calling. And we are returning value, the value that is returned by test, that will be stored in p. So what is p? P is an integer pointer. So test should return an integer pointer, and we have declared that test is returning an integer pointer. So let's see what is happening in the test function. So what are we passing? We are passing a. So what is a? A is 5. And we are passing address of b. What is address of b? It is 2002. So here in a we are passing 5, and this b is an integer pointer. That means this will store an address. Which address? This 2002. So in b we have 2002. So this b is different from this b. So this b is an integer pointer, and this b is an integer. Okay. So here 5 is coming in a, so we are copying this value here, and here b contains the address. Okay. Now we are doing int c is equal to a. So c contains which value? 5. Okay. C contains value 5. Fine. Now after that what we are doing? A is equal to 10. Now a is becoming 10. Which a? This particular a. So it is not this a. This a. So it is this a. So this is an a of test function. A of test function. So it will become 10. And now star b is equal to 20. That means go to this memory location. So what is this memory location? 2002. So that means this memory location. It will go here and it will update this value 20. So you can see the difference. When you are passing some variable as a pointer, it is updating the actual memory. So here it is updating the actual memory, that is the mains memory. Okay, but if you are passing it as a value, it is updating the memory of this particular function. So it is creating a new variable, and in that variable it is storing 10. So it is not updating the actual a. So pass by value, if you are doing pass by value, it won't update the actual value. It will update it as copy. However, if you are passing an argument as a pointer, and if you are updating that value in the function, it will update the actual value. So that is the difference between pass by value and pass by reference. So b is 20, so it will update it here 20. Now it is saying return c, return the address of c. So it has created c here. So in that c it was 5. We are returning the address of that c. So it is coming here. So p contains the address of c. So c. But we know that when a function ends, all its variables are removed. So all these variables, c is removed. Okay. A, it was creating a will also be removed. So that means in this case, we will receive the address of c in p, but it won't be of any use, because the memory that it will point, that memory has been removed. So here p becomes a dangling pointer. Why dangling pointer? Because we are saying that p will point to some memory, this c memory, but this particular function, when this particular function ends, this memory is removed, or this memory is deallocated. So it is pointing to an deallocated memory, so it will be a dangling pointer. Now after that we are doing printf a is equal to %d, b is equal to %d, and star p is equal to %d. So a is equal to %d. So a will be a is equal to %d. So a, value of a, what is the value of a? Value of a is 5, because this particular function has not updated the actual value of a. It updated the copy of a. So it will remain 5. But if we do b is equal to %d, so b has been updated. It will become 20. And this will give a garbage value, or it will give a segmentation fault, this one. Why? Because p is pointing to an unallocated memory, and it will give a segmentation fault. Okay, so my aim here was to make you understand that when you are passing some argument as a value, pass by value, then in that case it is not modifying in the function, it is not modifying the actual value, it will modify the copy of the value. However, when you are passing the argument as a reference, then it will modify the actual value. So you have to understand the difference between call by value and call by reference. And we also said that a function can return a pointer. So here we are returning a pointer in this program, but that is of no use. But we will see in some of the programs where this particular thing is very important, passing a pointer using a function. So let's come to the concept of arrays. How arrays are passed as arguments. Arrays as arguments. So let's see how arrays are passed as arguments. For example, if I have some function, and in that function, let's say I have a function that is finding maximum element in an array. Maximum element. Okay. So let's say the name of the function is maximum. It is taking an array as argument. So it takes array as an argument, and I'm saying that it will return the index of the element. So you have to remember, when you are passing array as an argument, array is always, whether it is a one-dimensional array, two-dimensional array, or any dimensional array, it is always passed as a reference. It is never passed as a value. Okay, what does that mean? For example, so let me write the same program. So this particular function, this function is taking array as an input, array as an argument. So let me say that, let me write a program hash include studio.h int main, and then let's say, or we can say here instead of index, it is returning maximum element. Maximum element. Okay, so int main, and then let's say we have an int array 10 is equal to 3 5 4 1 2 dash 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 10 elements. Now int max, okay, max is equal to maximum, and to pass an array we have to simply write the name of an array, because when passing an array as an argument, it will always pass by value. So we have to pass the address of an array, and then we will do printf maximum element is %d max, return 0. So now let me write a maximum function int maximum. Okay, then what is the argument? Argument is an int array. So this is how an argument, if you have an argument as an array, this is how you write it. So you have to remember that when you are passing array as an argument, there is no need to write the size of an array in the definition. Okay, in the definition there is no need to write the size of an array. So before definition we have to declare it here. So here I will declare maximum at int maximum, then maximum int a. Here also there is no need to write the size of an array. Here also there is no need to write the size of an array. Okay, so or you can write the size also, but you can ignore it also. Now in this function I have to find the maximum element in this array, but before finding the maximum element I have to find how many elements are in this array. So what is this A storing? This A is storing basically from here we are passing the address of array. Address of array, this particular array. So it is passed by reference. Okay, so that means when we are doing this, so in memory we have array. So it contains 10 elements. So array is here. Now here in this maximum we are creating, we are not creating another array here. Basically we are creating only one variable A, and this variable is pointing here. Okay, so first thing what we have to do is to find the size of this array. So how to find the size of this array? Let's say int s is the size. So what we are going to do, s is equal to size of A divide by, okay, size of A. Size of A divided by size of int. Okay, so size of A will give the size of this array. So it contains how many elements? 10 elements. So 10 elements and each element is an integer. So what will be the size of array? 20 bytes. So 20 bytes divided by size of int. So that is 10. So S will be 10. 10 means that this A contains 10 elements. Now we have to find the maximum. Let's say int max is equal to A of 0. So let's keep maximum as A of 0 initially, and then we have to run the loop for int I is equal to 1, I is less than s, I plus plus. This for loop I will write it here. If max is less than A of I, then max is equal to A of I. This will end the loop, and at the end we have to do return max. So I won't make you understand this particular thing because you already know how to find a maximum element in an array. So now we are returning max. So max will contain the maximum value and it will print the maximum number. So what I am trying to make you understand here, that whenever you are passing array as an argument, it is passed as a reference. It is not passed as a value. And this size in the argument, you can write the size or you can simply ignore it. So it is better to not write the size here. So this is when you are passing a one-dimensional array as an argument. Now let's say if you have to pass two-dimensional array as an argument. Okay. Now let's see how to find the, for example, we have to pass a 2D matrix, and let's say we have to find the sum of the diagonal elements, or we can say the multiplication of diagonal elements. So this is my matrix, let's say. So let's say the values are 2, 3, 4, 1, 2, 8, 3, 4, 6. So let's say I have to find the multiplication of diagonal elements. So it should be 6 into 2 into 2. 6 into 2 is 12. 12 into 2 is 24. Okay. So let's say this is my array int matrix, and the values, and it is initialized to 2, 3, 4, 1, 2, 8, and 1, 3, 4, 6. Okay, this is how you initialize a matrix. Fine. Now I want to find the sum of multiplication of its diagonal elements. Okay, so let's say I am using a function, or let's say int m, and m is equal to find multiply. So I am saying find the multiplication. That means this function will find the multiplication of diagonal elements, and I will pass this matrix as input. So this particular matrix. So we know every array, whether it is a one-dimensional, two-dimensional, it is passed as a reference. So we will pass the name of this particular matrix as an argument, and function will be, for example, int find max mul. So what is the argument of this function? The argument will be int array. For example, it is a two-dimensional array. So we have to pass two-dimensional array as an argument. So it is saying that this function is expecting which type of array? A two-dimensional array as an argument. And when you are passing a multi-dimensional array, you have to remember that in the arguments, or when you are defining it, all arguments should be specified, or we can say all these arguments means the size of it is dimensions. All dimensions should be specified except the first one. That means here I am passing here I am using an two-dimensional array. So first one I can skip this, but this particular argument should be there. For example, here the second argument is 3. 3 means that each row contains 3 elements. Okay, each row contains how many elements? 3 elements, or we can say each array contains 3 elements. So whenever you are passing a multi-dimensional array as an argument, then in the function definition, you have to specify all dimensions except the first dimension. So we have to specify all dimensions except the first dimension. So you have to remember it. Okay, or you can also pass this first argument. It is your choice. So for first dimension, it is your choice. You can skip it or you can use it. Okay, however, the other dimensions should always be there. You cannot skip the other dimensions. So let's see, we are passing it here both the arguments. So here this matrix will come here. So this matrix address will be copied in this. So it is passed by reference. Then we can do, for example, int a. Then for I is equal to int I is equal to 0. I is less than, let's say here we have 3, and here we have 3. I is less than 3, and I plus plus. For int j is equal to 0, j is less than 3, j plus plus. Then I am doing, let's say int a is equal to 1 initially. A is equal to a into array, or sorry, let's do it like this. So no need to enter the second loop. A is equal to a into array I. So, and then at the end we have return a. So here it is doing a is equal to a into, so first time it will be 1 into array 1 0 0, sorry 0 0. Second time it will multiply array 1 1, and the third time it will multiply array 2 2. So this array is basically a pointer to this matrix. Okay, so it will take this, the first element, it will be 1 into array 0 0 is this element, so it is 2 into array 1 1 is this element. So it is 2 into array 2 2 is this element. It is 6. That will be 24. This 24 is stored in A, and this is returned here. Okay. So what we have understood up to this point. So first point is, when arrays are passed, they are passed as a reference. Second, when we are passing a multi-dimensional array, then in the definition all dimensions of an array should be specified except for first dimension. You can specify the first dimension or you can skip it. But for other dimensions, it is necessary to pass those dimensions as well. So now let me write one or two more programs in which we will understand how arrays are passed as an argument, and also how functions are returning the pointers. So we will write one or two examples here to understand it. So let me write the example here. For example, let me do it. So let's say, so I will only write a function. Okay, so let's say this is function char star. The name is, let's say, test, and then for example it is taking char star s and char star ss a pointer. So this test, it is taking input as a pointer. This pointer is pointed to an character array. Okay, let's say for example we have character array s, or we can say s we have is equal to char s is equal to hello. Now let's say test is checking whether there is or we can say test, what is test doing? Basically it is updating this array, or we can say it is updating this string. Instead of hello, it will write HELLI. Okay, so last element it wants to update, that is HELLI. So last element it wants to update. So what is test doing? Update, change last element to I. Whatever the string is, last element should be I. Okay, so and then return the pointer. Return the pointer to some other location. Or we can say, for example, we have another char star new. So new is equal to test s. So let's see what will happen. So this test is passing this pointer. So this pointer here, it is an address to an character array. So I am receiving it here. Now first we will do, so int I is equal to string length s. So we will find the length of this string. Okay, then we have to update the last one. So last one will be I minus 1. Okay, so we have to update I minus 1. So that means s of I minus 1 should be equal to I. And then we will do return s. So let's see what is this program doing. So basically this program, it first creates an array s, and in this array we are storing hello, HELLO. So this is s of 0, this is s of 1, this is s of 2, this is s of 3, this is s of 4. Now we are creating another pointer new. So this is new. Okay, it is not pointing to anything now. So new is calling test. So we are calling this test, and it is taking this argument, so this address. So it is taking this address as an input. Now it is doing int I is equal to string length s. It will find the length of this string. What is the length? 5. So now s I minus 1. So 5 minus 1 will be 4. S of 4 will become I. So s of 4 will become I. then it is returning S. Returning S means returning this address. So this address will be stored here. So now new points to here. Okay. Now you can access this particular array using this pointer or using the name of the array. So this is how pointers or arrays are passed as arguments in C programming languages. I will provide you some of the programs that you should use, and you should try out those programs and see how we can use how we can pass arrays as arguments in C programming languages. Okay. So let me write one more example that will be returning pointers. So for example, let's say this is hash include studio.h. So let's say this is my function int star fun, and it is creating variable int a is equal to 5, then return address of a. And let's say I have int main. So this is a function and it is returning which? Integer pointer. Okay, it is returning an integer pointer. So let's say I am creating p, then p is equal to 1. So then printf value is %d star p return. So let's see what is this program doing. Return 0. So int main will start. So it is creating a pointer. So this is my function. So it is creating a p pointer. So it is not pointing to anything yet. So it is a wild pointer. Okay. So if I did p is equal to null, then it will be a null pointer. Now p is equal to function. We are calling this function. Okay, so what is this function doing? It is creating a is equal to 5. So a is here, it is putting 5 in here. Let's say its address is 2000. Okay, then it is returning the address of a. Returning the address of a. So what is the address of a? 2000. It is returning 2000. That means it is returning integer address. It is returning the address of a variable that is an integer. So it is returning integer pointer. Also, when this function ends, that means this is returning. This particular memory will be deallocated. So this 2000 will come here. Now I am doing printf value is %d. This value. So it is dereferencing pointer. Dereferencing pointer means get value stored at, what is p storing? 2000. Now 2000 is this memory, but this memory has been deallocated. So we won't be able to get this address because this memory has not been allocated to us. So it is an illegal memory operation. So it will give a segmentation fault. So this program helps you to understand how to return pointers and what is the issue if you are returning a pointer and you are pointing to some memory location that has been removed. Now, instead of int a is equal to 5, if I have static a is equal to 5, int a is equal to 5. So again, the same thing will happen. P will be created. It will initially store null. Then p will call function. This function is called. So it will create a static variable a. And let's suppose it is address is 3000. It will store 5 in this. Now it is returning the address of a. What is address of a? It is 3000. So it is returning. And this function is ending. But you have to remember and you know that whenever a function creates a static variable and that function ends, the static variables are not removed, are not deallocated. They are deallocated only when the program ends. Automatic variables are deallocated when the function ends, but a static variable is not deallocated till a program is running. So this memory won't be deallocated. We are returning an address. This address will be stored in P. Now P contains 3000, and when we are doing value is %d, value is %d, which P, we are dereferencing pointer, so it is getting this value 5. So it will get this value. Why? Because this memory has been allocated to our program and it has not been deallocated yet. So it is a valid memory, it will print the value. So this is how you can, what is the difference between static and automatic variables. So this program helps us to understand how to return pointers from functions, and also what are the issues that you have to take care while returning pointers from functions. Also, for example, what is the use of returning pointers? So why there is a need to return a pointer? For example, what I am saying here. So now let's see how we can return an array, or we can say how we can return multiple elements using multiple elements. So for example, I want to create a program. That program should create an array. So it will use a function. That function should create an array, put elements in that array, and return that array to the main function. So let's do it like this. For example, let's say I have function int star get array. So what is the function of this particular function? The main use of this function is that it will create an array. It will create an array, and it will add elements to that array and return that array to main. Okay, so let's see how it will create an array. So let's say, for example, int star p, it is doing p is equal to int star malloc 10. So here it is creating an array that can hold how many integers? 5 integers. 10 will be 10 divided by 2, that is 5. So it will create 5 integers. Okay, then we are doing for int I is equal to 0, I is less than 5, I plus plus scanf %d p of I. So here we are entering elements in the array. Then we will return this p, this pointer p. So this p is pointed to an array, and that array contains how many elements? 5 elements. Okay, so using this integer pointer, we can return the address of a pointer array. Okay, and that pointer, using that pointer, we can access different elements of an array. Now in main, for example, int main. So if I am doing, for example, int star pointer, then I am doing pointer is equal to get array. Then I can print, I can do for int I is equal to 0, I is less than 5, I plus plus printf %d, then ptr I, return 0. So let's see what is this function doing. Int main, it is saying, it is creating a pointer. Okay, this pointer ptr. Now ptr is, it is calling get array. It will go here, it will create a pointer. Now that the memory has been allocated here, okay, it is adding elements to this array, this p array. So pointer or a p array, we can access it in both the forms, using an array form or a pointer form. And then we are returning this p, the address of this array which we are creating. Okay, this address will be stored in this pointer. So that means using this pointer, you can access the elements of that particular array. Okay, now why are we using malloc here? Why can't we simply have p as an array, let's say 5, and then instead of doing this, add elements like this and then return p? What will be the issue? When we are returning p here, this function has created this memory, But when this function ends, when it is returning, this memory will be deallocated because it is a static memory. Static memory is deallocated when a function ends. Okay, so that means if now I am using this pointer to access this particular array, it will give a segmentation fault. However, when I am using this malloc, it won't give segmentation fault. Why? Because a memory that has been allocated dynamically, that memory is not deallocated automatically. It is deallocated only when it is freed exclusively. Okay, so this memory will remain. However, if I am doing simply p of 5, that memory will be removed automatically when this function ends. Okay, so that means when you are returning an array or an array pointer using a function, that array should be dynamic. That function should be, or we can say that array should be either dynamically allocated or it should be a static array. If you are using an automatic array and you are accessing the same array in the main program, it will give you a segmentation fault, because in that case that pointer will be a kind of dangling pointer. Okay, and dereferencing a dangling pointer will result in a segmentation fault. So with this, I will stop the discussion about the arrays, about how we can pass pointers as arguments in arrays, how 1D arrays, 2D arrays are passed as arguments, and how to return the pointers from a function. Now we have to discuss one small concept, that is and after completing that concept we will end this particular lecture, and that is function pointers. So up to this point we were saying that we have a pointer and that pointer points to some data. Now if we want to use a pointer that points to a function, so because we know a function is stored in memory, so every function has a base address, so that means if there is some pointer that points to that function, that pointer will be called a function pointer. Okay, let's see how function pointers are declared and how they are used. Okay, let's say I have a function, for example, so before this you have to see what is the prototype, how function pointers are declared. Return type, then we have brackets, then we have pointer, then name of function pointer, and then arguments. So this is how a function pointer is declared. Okay, and you have to remember, for example, when we have an array, let's suppose array. So what is this array? Array name is the address of array. Likewise, in case of functions, if you have some function, for example add, it is a function, then the name of the function is the address of function. You can directly use name, or if you add and, that is also same. So if you do and add, that is also the address of function, and if you simply write the name, that is also the address of function. So this is how function pointers are declared. So this will be a function pointer. So name here is a function pointer. Okay, now if I have to give the value to this function pointer, or we can say to which function it points. For example, if there is a function add, then I can do name is equal to add. So that means this function pointer is pointing to this particular function, or I can simply do name is equal to add. Let me write a small program, then we will see how function pointers are used. So let's say I am writing a program, hash include studio.h, then I have int add, int a, int b. So let's say this function is return a plus b. It is returning a plus b. So let's say in main I have, for example, I am creating a function pointer, int star function pointer, name is function pointer, let's say, and this function pointer it can point to a function that takes, let's say, two arguments, int comma int. So this function pointer can point to a function that takes two integer arguments. Now this function pointer, we are saying that it is pointing to this function, or for example it is pointing to a function add. So that function has been defined here. Okay, you can write function pointer is equal to add, or f is equal to, this will be c. Okay, now you can simply, for example, int c, you can do c is equal to add 2 3, or you can do c is equal to star fp 2 3. This and this is same. So you can access this particular function using a function pointer, or you can also do it like, for example, fp 2 3. This will be also same using star fp or fp. Okay, so this is how function pointers are used in case of C programming language. So a function pointer is a pointer that can point to a function. Okay, so here I am declaring a function pointer and I am saying that it is of type int. Okay, or we can say it will return int and it will take two arguments as int. And this type of function, the function that is returning, that is taking two integer arguments and is returning int, I can give the address of that function to this function pointer. Okay, now let's see what is the usefulness of this function pointer. So let's see, for example, let's say I have function is int add int a comma int b, and it is returning a plus b. Then I have int sub int a comma int b, and it is returning a minus b, and int multiply int a comma int b, and it is returning a multiplication by b. So we will see the usefulness of this of the function pointers. Okay, now as you know that we have already discussed the function pointer. Okay, function pointer, it is a pointer that can point to a function. So like function pointer, or we can say like pointers, in pointers we can create array of pointers. Likewise we can create array of function pointers. Array of function pointers. Let's see how will we use it. So array of function pointers means that array that will contain multiple function pointers, and those multiple function pointers can be used to point to multiple functions. So for example, if now I have main function int main, let's say I am creating an array function pointer. So how is function pointer created? So this will be a return type. For example, I want to create a function pointer that can point to this function, or this function. So how many function pointers I have to create? 3. Okay, let's say, or what should be the type of function pointer? It should be like this. For example, star function pointer, the name, and what should be the arguments, int. So if I do fp is equal to add, that means fp is pointing to add. If I did fp 2 3, so which function it will call? It will call this function. Now if I did fp is equal to sub, So which function it will call? Sub. If I did fp is equal to multiplication, which function it will call? Multiply. Okay. Now let's say, for example, I want to create 3 function pointers. One function pointer should point to add, another should point to sub, and another should point to multiply. So I have to create, this is my function pointer. Okay. It should be of type this, int and int. Okay, this is a function pointer. But I want to create an array of pointers. So how many pointers? 1, 2, and 3. I can simply write it here. That means it is creating 3 function pointers. The first function pointer is fp0, the second is fp1, and the third is fp. Then I can do fp0 is equal to add, fp1 is equal to sub, and fp2 is equal to multiply. Now if I have to call add, I can simply do fp0 to 5. If I have to call sub, I will do fp3 4, for example, if I am doing, and fp for multiplication I will use fp2 5 6. Or else you can simply do it here, like for example, like you are doing in arrays, you can do add sub multiply. So fp0 will point to add, fp1 will point to sub, and fp2 will point to multiplication. So this completes the discussion about the pointers and how we can use pointers in C programming language. So in the last 2 lectures and in this lecture, we completed what is a pointer. We also completed arrays and pointers. And we also did a discussion about dynamic memory allocation. And we also discussed different types of pointers. And we also discussed use of pointers in functions. And also we had the function pointer. So with this, I will stop this particular video here, and with this also we have almost completed all the important concepts that are related to the pointers. Okay, so in the next lecture we will start discussion about the structures and unions. So let's meet in the next lecture. Till then, goodbye.